Hello my dear students, how are you? I hope and I wish that you are well in your house. In this class, we will discuss about the previous year's questions of the topic mole concept. We discussed in the previous classes. So in the mole concept, you studied about the relations of mole, concentration terms, stoichiometry, limiting reagent, laws of chemical combination, and also about the empirical and molecular formula that we already discussed. Now it is time to discuss the questions which have been asked in previous years NEET and JEE examination from this topic. So let's start and solve some very good questions.
So this is the today's session of previous year questions of mole concept. Now in this class we will solve some previous year's questions which were asked in the entrance examination of NEET, or previously it was called AIPMT, All India Pre-Medical Test, or the questions asked in IIT JEE examination. So come and let's solve some questions. Now this question which is in front of you, what is the maximum number of molecule present in? The maximum number of molecule present in means examiner is asking in which of the following option number of molecules, students please remember he's asking number of molecule is maximum. So now you have to find out, you have to calculate that in which option number of molecules are maximum. In order to calculate the number of molecules, first we should calculate the number of mole. See, first option is 5 liter of nitrogen, it is gas and at STP. So here's mole will be given volume by 22.4. As we already know that formula of mole in terms of gas at STP is given volume divided by 22.4 liters. Yes. In the second option, mass is given. So in this case, I will say mole is given mass, that is 0.5 divided by the molar mass of hydrogen, which is 2. And what about 10 gram oxygen? Its mass, mole will be divided mass, given mass 10 divided by the molar mass, which is 32. And here it is 15 liter of hydrogen. So for 15 liter of hydrogen, number of moles will be given volume 15 divided by 22.4. Now in case of first option, if you solve it, it will come 0.22 mole. In the second option, when you will divide 0.5 by 2, it will come 0.25 mole. In the third option, which is 10 divided by 32, it is 0.312 mole. And in the fourth option, whereas it is 15 divided by 22.4, it will come 0.669 mole. We know that number of molecule, we already studied in the unit, that number of molecule will be equal to, my dear students, number of mole into Avogadro's number, and Avogadro's number is common. So the option in which number of mole is maximum, number of molecule will also be maximum. In which option number of moles are maximum? Yes, you are right. The right answer is option number 4. So fourth will be the right answer of this question. Alright. Now here we go with the another question. Second question. Now the second question says, students, you know, this reaction which is given in the second question, this is the reaction of metallurgy of aluminium. Now this reaction says what the mass of carbon anode consumed, giving only carbon dioxide, in the production of 270 kilogram of aluminium. So what all you have to do, my dear students, you have to form 270 kilogram of aluminium. Alright. And for this, how much carbon is required? This is the question. Now this question belongs to stoichiometry. If you write down again the balanced reaction, Al2O3 plus 3 carbon gives 4C plus 3 CO2. It is 4Al actually. 4Al plus 3 CO2. Alright. Now what is the stoichiometry here? Here it is 1. Here it is 3. Here it is 4. And here again it is 3. So the stoichiometry is 1, 3, 4, 3. Now we are concerned with the carbon and aluminium. 270 kilogram of aluminium. What is the mole of aluminium? It is given mass 270 into 10 to the power 3 divided by 27, which is the molar mass of aluminium. So students, it will come 10 to the power 4 moles. So how many moles of aluminium you have to form is 10 to the power 4. Now, as per the stoichiometry, for 4 mole of Al, for production of 4 mole of aluminium, we need 3 moles carbon. What about 1? For 1 mole, for the production of 1 mole aluminium, we need 3 by 4 mole carbon. And what about 10 to the power 4? Because you have to form 10 to the power 4 moles. So for 10 to the power 4 mole aluminium, students, we will require 3 by 4 into 10 to the power 4 mole of carbon, which is 7500 mole of carbon. But you see, this is not the option, because option is asked in terms of mass. So what is the mass of? We know, everybody know that mole is equals to given mass upon molar mass. So for what would be the mass of 7500 moles? Mass of 7500 moles will be, mole is 7500 into molar mass of carbon is 12. So the right answer of this question would be option number 4, 90 kilograms. This will be your final answer. Alright, my dear students. So for the production of 270 kilogram of aluminium, students, for the production of 270 kilogram of aluminium, we would be required 90 kilogram of carbon as anode. Now we will move on to the next question, which is here in front of you. Now it says, what volume of oxygen gas O2 measured at 0 degrees Celsius and 1 atm, which is the condition of STP, is required to burn completely 1 liter of propane. What is propane? C3H8. This question was there in AIPMT 2008. Students, now in order to solve this question, you have to write down the equation of burning of propane gas. You have to write down the equation of burning of propane gas. So how you will write down the equation of burning of propane gas? See, here we go. This is the balanced chemical equation. C3H8 gas plus 5 oxygen gas gives 3 CO2 gas plus 4 H2O liquid. Students, you can check. This equation is balanced equation. So it simply says the stoichiometry is 1, 5, 3 and 4. And students, if you remember, I told you in the lecture of stoichiometry that you can read the reaction in terms of the stoichiometry. If they are for the gaseous species, whatever the ratio of stoichiometry could be considered as the ratio of their volume. So I can say if 1 liter of this will consume, 5 liter of this will consume, and 3 liters of CO2 will produce, although we will not consider volume of this water because it is liquid. So Our question was for 1 liter of propane. Now it is clearly visible that for 1 liter of propane, how much volume of oxygen is consumed? Is 5 liter. So our right option will be option number 1, 5 liters. Alright, next question. In this question, it is asked, how many number of atoms in 0.1 mole of triatomic gas is there? It means it was given simply that we have a triatomic gas. Triatomic. Do you know what is the meaning of triatomic? It means in this gas, one molecule contains 3 atoms. It is A3 kind of gas. If examiner says it is diatomic, it means it is A2 kind of gas. If he says it is monoatomic, which means it is A type of gas. Only one atom is there. In diatomic, 2 atoms are there. In the triatomic, 3 atoms are there. So what all we have is number of mole, which is given already 0.1. Now I told you in the theory of mole concept already that how to calculate the number of molecule. It is very easy. Molecule is always equal to mole into number of Avogadro. So molecule is equals to mole into number of Avogadro. So how many moles? 0.1 into number of Avogadro, Na. How many molecules are there? 0.1 Na. Now for triatomic, it simply says A3, which means one molecule contains 3 atoms. So how many total atoms are there? But it is a very easy question. How many total atoms are there? How many total atoms are there? So total atoms will be equal to the number of molecule multiplied by 3, because each molecule contains 3 atoms. So total atoms will be, number of molecules we have 0.1 Na multiplied by 3. Now if you put the value of Avogadro's number, 0.1 into 6 into 10 to the power 23 into 3. Students, it will come somewhere around 1.8 into 10 to the power 23. So option number third will be your right answer in this case. This will be the total number of atoms present in 0.1 mole of triatomic gas A3. Now question number 5. Which has the maximum number of molecules among the following? Now you see, in all the options, mass is given, and what examiner is asking, number of molecules, not atoms. Simply he is asking number of molecules. This question was there in All India Pre-Medical Test main examination in 2011. In order to find out number of molecules, first we have to find out the moles. For all of them, mass is given. Simply we will calculate mole by dividing molar mass. So its mole will be 64, which is given mass, divided by the molar mass, which is again 64 for SO2. Here given mass is 44, and coincidentally again molar mass of CO2 is 44. Here given mass is 48, and if you find out molar mass of ozone, which is O3, 16 into 3, again it is 48. And if you calculate number of moles of 8 gram hydrogen, it will be 8 divided by the molar mass of hydrogen, which is 2. So here number of mole is 1, here also number of mole is 1, and here also number of mole will be 1. But students, here 4 moles are there. So these are the number of moles. Now everybody knows, I told you so many times, molecule is, how to calculate the molecule? It is very simple. Molecule is mole into Na. So students, this will be Na molecule, here will be Na, here will be Na, and here 4Na. 4Na molecules. So which one has the maximum number of molecules now? Now you can answer this question very easily. Which one has the maximum number of molecules? And yes, you are right. The right answer is 8 gram of hydrogen. Very good. All right. So these were few questions which were asked in the previous year All India Pre-Medical Test. Now, I would like to show you some questions of IIT entrance examination. This question was asked in Joint Entrance Examination 2003. It says, calculate the molarity of pure water using density to be 1000 kilogram per meter cube. Decimeter cube is 1 liter, per meter cube we are asking here. So now we have pure water. This is subjective question. This is not objective question. What you have, students, is pure water. How much pure water you have is 1 liter. Say for example, if we take 1 liter is 1000 milliliter. As density is 1 gram per ml or 1000 kilogram per meter cube. Now if density is 1, 1000 ml will be equal to 1000 gram because density is 1. So 1000 ml is equals to 1000 gram. Now what is the formula of molarity we know? How to calculate the molarity? Molarity is given mass, which is 1000, upon molar mass. For water, molar mass is 18 into multiplied by volume, which is 1 liter. Now if you will solve this equation, students, it will come 55.5 mole per liter, or you say 55.5 capital M. So students, this will be the value of molarity of pure water, 55.5 mole per liter. All right. This was the question in Joint Entrance Examination IIT 2003. Now another question. Which has maximum number of atoms? See, this question was there in 2003 IIT JEE Entrance Examination. Which has the maximum number of atoms? So you see, all these species are atomic species. There is no compound or molecule. So first of all, again, you have to calculate the moles. We have to find out the number of mole. How many moles are there? This we have to find out. In the option number A, students, if you have a look, how much mass is there? 24 gram. So mole will be given mass 24 by atomic mass 12, which is 2. In the option number B, given mass is 56, while the atomic mass of iron is again 56. So here will be 1 mole. In the option number C, 27 gram aluminium. So given mass is 27 upon molar mass of atomic mass of aluminium is again 27. So here also 1 mole is there. Now in option number D, how many moles are there? Given mass 108 divided by the atomic mass of silver, that is again 108. So here also 1 mole will be there. All right. So now you say, where we have maximum number of moles? Obviously it is very clear now. In the option number 1, we have maximum number of moles. And if we have maximum number of moles here, students, number of molecule will also be maximum here. But in this question, atoms are asked, so number of atoms will also be maximum in the option number A, first option. Now the other question. This question is based upon stoichiometry. It is very simple question, students. It is simply based upon stoichiometry. This question says, calculate the amount of calcium oxide. Calcium oxide is what? CaO. So you have to find out the amount of calcium oxide which is required when reacts with the 852 gram of P4O10. So basically you have to consume 852 grams of P4O10 and you have to find out that for this how much mass of calcium oxide would be required. So first, in order to solve this question, first we see the stoichiometry. Stoichiometry is 6, 1 and 2. Simply, what is the molar mass of P4O10? Now everybody knows atomic mass of phosphorus is 31, which is multiplied by 4, plus atomic mass of oxygen is 16 multiplied by 10. In total it will come 284. How many moles of P4O10 are there? Mole of P4O10. How to calculate mole? Very simple. Given mass 284 divided by molar mass. Let me correct it. Given mass is not 284 students, it is 852. And the molar mass is 284. So there will be 3 moles. When you will solve this, you will get value 3. So you have to consume 3 moles of P4O10. Now you see, as per the stoichiometry simply says when 1 mole of P4O10 is consumed, CaO required 6 mole. So when 3 moles of P4O10 are consumed, calcium oxide requirement will be 3 into 6, my dear students, 18 moles. Now we need 18 moles calcium oxide. Now what is the moles? What is the mass? We know that mole is equals to given mass by molar mass. By using this formula, number of mole is 18, which is equal to given mass W divided by the molar mass of calcium oxide 56. When you will solve this, the value of W will come 1008 grams. So this would be your answer of this question. How much mass of calcium oxide would be required? 1008 grams. This is the mass of calcium oxide would be required for this much of P4O10. Now the last question. In this question, examiner simply says that we have isotopes of iron. We have 3 isotopes precisely: iron 54, iron 56 and iron 57, and their relative percentage in which they are found in nature are 5%, 90% and again 5%. In this case, now we have to find out the atomic mass of iron, which will be average of all of the isotopes. So we know the formula of average atomic mass. M average is precisely calculated by using the formula M1x1 plus M2x2 plus M3x3, which is divided by x1 plus x2 plus x3. Students, I told you already what are M1, M2 and M3 and what is x1, x2 and x3. These M1, M2 and M3 are the mass number of different isotopes of iron, while x1, x2 and x3 are their relative percentage of abundance or their ratio. So here in this case, if I say M1 is 54, so it is 54 multiplied by its percentage, which is 5. Then again next isotope is 56 multiplied by its percentage, which is 90, plus another isotope is 57, which is multiplied by its percentage, which is again 5, divided by the total percentage x1 plus x2 plus x3, 5 plus 90 plus 5. When you will solve this, students, you will, what value you will get is 5595 divided by 100. So average, M average will be 55.95 AMU or U, because we know that atomic masses are represented in U. So these were the few questions we have solved in this unit, mole concept, and now you can see that it is very easy to attempt the numericals, solve the questions if you have command on theory. So hopefully we wish and we expect We have a firm belief that now you would be able to solve the numericals as well, and we wish you good luck. Alright students, now I'll see you in the another class of next chapter. This was all about the chapter mole concept. Take care and keep studying. Thank you.